Let's look at some practical applications of exponential graphs, because you guys always want to know, how are we ever going to use this? Well, some things in real life grow exponentially, like money, which is cool. Money, if you put it into the bank, it grows if the bank's doing okay. We've looked at this before. Say we put 100 euros into the bank. Let's say there's a 4% interest, which right now it isn't. It's much lower, but in better times you could get 4%. When you put it into the bank, so in year one, let's say this is time. So before we start, before the money starts growing, time is 0. We put it in and it's 100 euros, right? After a year, we get our 100 euros plus 4%. So 104 euros in the bank. And remember how we used the formula where the amount equals the principal amount times 1 plus the interest rate to the power of time in years. In this case, it would be the amount in the bank, we're calling it A, equals the 100 euros we started with, times 1 plus the interest rate as a decimal. That would be 1.04, right? 1 plus 4%, 4/100ths, to the power of t. So t is like our x value, right? T is what goes into the function, and a is what comes out, our new total amount. All right, so we can find the amount of money we have in the bank after 2, 3, 4 years by just plugging in that value for t. So 1.04 to the power of 2. We need our calculator there, or at least I do. 1.04, goodness, there's no power here, times 1.04 equals this, times 100, so let's say $108, euros, and 16 cents. Let's plug that in here, 108, 16 cents. We can do the same for after 3 years. So this was 1.04 times 1.04, so I'm just going to say times 1.04 again, so I'll have it to the power of 3 times 100 would be 112.49, etc. So see how our money is growing year by year. It's not doubling, but it's adding 4% each year, and the increase is higher each year because it's exponential. Here we gained 4 euros. Here from year 1 to 2 we gained a little more than 4 euros. See? We gained 4.16. From 2 to 3 we gained more than 4.16, because that would have been 32 cents. So the increase just keeps getting higher. And that's always true in an exponential growth. And if we plot these points on a graph, we can estimate, like, when are we going to have 200 euros in the bank? Or, you know, we could even, again, look at the slope of our graph in any given point. This is not the graph of this one, but it, you know, has the same shape. So it's not just something fun mathematicians like to do because they like the way these graphs look. It's something that, you know, describes real life situations, like money growing in the bank or bacteria growing. If you start out with one bacteria, is that what they look like? I think so. It'll multiply. Actually, this is cell growth too, right? Where an embryo starts to grow. Each of these two cells splits up, and they, like this one, becomes two new cells, and this one splits up, makes two more cells. And then if we wait the same amount of time as we did here and here, we'll have 8 cells, right? And it just grows exponentially. It's not like, because see here, what's been added from here to here is 1 cell. From here to here, in the same amount of time, 2 cells have been added, right? From here to here, same amount of time as between these two steps, all of a sudden there's 8, so that's a change of 4. So the growth keeps increasing. Awesome. It's real life.